Hey, what's up, everybody? Never been so excited to get back from Target in my life. I've been looking at this thing for like 3 months. At the time, it was like $35, which ultimately is really inexpensive. It's the Tech Will Save Us mini synthesizer kit, and it's really cool. It went on sale recently. It's now $17.50, and inside is a lot of really cool components. When you open it up, there's all these little baggies. These are potentiometers and a little speaker, right? This is a breadboard.
It's a speaker, yeah.
We have a really great shop called Skycraft in Orlando where you can buy stuff like this. If you went up and bought this at a place like that, it's basically like a Radio Shack. What's that? This is a chip, and when you plug this into the breadboard, it makes an oscillated signal that you can modify to make sound. Hang on, buddy. See, these are capacitors and resistors. This is a circuit board we recently opened up out of a television. It has all the same types of components, right? It's got resistors and capacitors and all the other things to make a circuit board, which is cool. So what we're going to do is we're going to sit down and make this. But basically, if you went to Skycraft, this place that's a lot like a Radio Shack used to be in Orlando, and bought this breadboard, it'd cost you $7 or $8. This would be a $4 speaker if you didn't pull it out of something else. You'd have to design this. This is a chip, a microchip for making an oscillator. And if you don't want to learn how to be an electronics engineer before you get to make your first synthesizer, you need something like this. So you can't just buy that anywhere. And it came inside of this kit for $17. It even came with a faceplate, so you can like install all of this inside the faceplate and build your own thing. It's affordable. It's simple. It's something you can teach your children, and it's also hackable. So like, I have a digital delay pedal for my guitar. I can put outs and ins and put a new speaker in it and do all kinds of things. There's even an open source website where you can manage all of these components into something different. And it's just really cool.
Yeah, so
like, do you want to make a synthesizer today? Does that sound fun?
Yeah, and
look at this. So here's what we're going to do. We're going to sit down and get all of this set up and organized so that we can make it more easily. And we'll be right back. And I think this is going to be really worth doing. So
I was going to do this while you were doing that.
All right. So we got the box open, pulled all the parts out, got this instruction booklet opened. Basically, all the instruction booklet is like some of the different things you can do with this kit. It has your components list and then a link to a website where you go online and can look at the different instruction manuals for making different components for this. I also got everything laid out here. This is a piece of styrofoam that I cut off a board I was making a balsa wood model with, and I like to stick all my electronics components into that. Just keeps them organized. If you got 2 kids running around grabbing at stuff, you know, you're less likely to lose stuff if you've got it all in one place stuck to this board. So that's what I do. You know, I like education products, but I don't like things that patronize me and my kids, you know. These are real parts. This is a breadboard. If you're going to go and design a product like this and have this circuit board printed, you're going to start on a breadboard like this. All the connections, you don't have to solder any of the connections in, so you can test things. Things cannot work. You can take it apart and put it back together without ruining stuff. And so, like, this is all real stuff. These are resistors, and those are capacitors, and this is a potentiometer, which alters voltage. So you can take this sine wave, I'll explain it later, but I mean, you can take this sine wave of your power supply and alter it so that it makes different sounds. And there's a little push button, so you can do different things with it. You can turn the synth on and off or set tempo with it, depending on what it tells you to do. This is the chip that forms all of the real brain components for the oscillator. This is terminals for installing a 9-volt battery. some jumper wires to bridge between components on the breadboard, and a speaker. There's a couple others, but we're starting on the first level, so this is all we need for that. So I've got it all laid out and ready to go. And we're gonna sit down and build this thing, see what it sounds like. This thing's awesome. What ended up coming out of the kit was actually a really cool instrument. It's been fun to play with. The fact is, it's not particularly user-friendly, which is part of what I like about it, because whenever you're making something, designing a circuit or doing woodwork or whatever it is, most of the time you're really not learning very much unless you're failing at it. And this is, if you've never built something out of a breadboard, which I haven't, this is kind of difficult to get correct the first time. You got to really follow instructions. As far as I can tell, you're not going to burn anything out if you get it backwards, but it won't work. And there's a little bit of frustration in that, and I think kids need to feel that stuff. Like, I'm glad that they didn't engineer all the difficulty out of something like this. Your 5-year-old's not going to be able to build it. But they can sit there and see you go through the process and not being able to figure it out and wiggling stuff and trying to see if you can't get it to make connection, and they can see you failing, and then in the end you've built something that's kind of cool and they enjoy. So overall I think this is really fun and cool, and I think you can do one of two things with it from this point. Like, pack it all up, put it back in the box, maybe print off some instructions off the internet, and wait for the box to get dusty. And then when your 12-year-old is interested in music or whatever else, you pull it out of a box and say, here, go build this thing. Unless you have a 12-year-old, in which case you just let them build it. But, the other option is this comes with so much information. I was looking around on the internet a little bit. You can build 3 different circuits with it just off of instructions that are downloadable off the website. But then there's forums and a SoundCloud thing of different things that people created with it. And you could design your own box and install these, maybe take these less expensive potentiometers, replace them with something a little nicer, and maybe make all 3 modes that it gives you the instructions for, and make it switchable, that kind of thing. You can hack it and design it. It's a working, living piece of electronics that now you can go and do what you want with it. So I think it's really interesting. It was a well-spent hour of my time, and I think it was, it's something that the kids definitely enjoyed. So bottom line, if you got a $20 bill burning a hole in your pocket, and you want $2 of it back for something else, this is a good way to spend that $17. Thanks to my wife helping me figure out how to build this stupid thing. And thank you for Tech Will Save Us. You made a pretty cool product. Thanks for watching. Cool, dude. What'd you make?
An instrument panel.
An instrument panel?
Yeah.
Electronic?
Yeah.
Oh, cool. Can you name me a part on there?
The instrument panel.
Are there any capacitors?
Yeah.
Or resistors?
Yeah.
Here, you push the button. You push the button and you turn the knob, okay? You turn the knob, man. There you go. Here, you know what's cool? Look at this speaker. Here, put your finger on there. Put your finger on there, Ian. Feel that? That's the speaker bouncing up inside there, and it makes a vibration that you can hear with your ears. It makes sound waves out of the speaker.
It
Isn't that
needs to
cool?
go up here.
Wow. All right, boys. Well, let's keep having fun with it.